Boys and girls, this is Mr. Manise. Welcome to this video, and in this video I am going to walk you through how to work each of the problems on our statistics unit test review. So my disclaimer as always, I'd like for you guys to work these problems on your own and then come to the video and see what misunderstandings or clarification you might need. So let's go ahead and jump right in. So number one, we're back to our box plots and mean, median, or measures of spread. And it says, Brandon asked 40 students at lunch, how many text messages do you send and receive each hour as they walked in the door? The results are displayed in the dot plot below. Okay, so I've got a bunch of data here. So the easiest thing to do, guys, is just to list out each of these different numbers. Okay, I know this will be a little bit tedious, but I have 3 ones. So I have 1, 1, 1. 2s, I have 4 of those. So 1, 2, 3, 4. 3s, I have 5 of those. 1, 2, 3, 4, 5. The 4s, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of those. 3, 4, 5, 6, 7, 8. And the 5s, I have 1, 2, 3, 4, 5. I got 6 of those. 1, 2, 3, 4, 5, 6. 6s, I have 1, 2, 3, 4, 5. 2, 3, 4, 5. 7s, I have 3. 8s, I have 3. 9s, I have 2 of those. And I have a 10. Okay, so now I'm ready to plug all this data into my calculator. So if you guys will bust out your trusty calculator, I'm going to go to Stat. I want to edit my list. Okay, so let's edit. Now remember, guys, I explained this on an earlier video, I believe, but when you're going up here and you want to clear this list, do not go up to list 1 and press delete. Please don't do that. Okay, if you press delete, okay, notice L1 is gone. Okay, your entire list has disappeared. And to get it back, you would have to press second insert, and then come down here to list 1, second list 1, and I have to put it back. Okay, so you don't want to delete the list, you want to clear it. All right, so press the clear button, enter. Okay, now my list is cleared and I'm ready to type in all of my data. All right, so I'll do this kind of fast here just for speed purposes. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And I got 1, 2, 3, 4, 5, 6. I have 5 6s. 1, 2, 3, 4, 5. 1, 2, 3 7s. 1, 2, 3 8s. 2 9s and a 10. Okay, so that's a lot of stuff. So I'm going to go back and make sure that I typed all this in correctly. It's just a good practice, a good habit to get into. Okay, so I have 1s, I had 1, 2, 3. 2s, I had 1, 2, 3, 4. 3s, I had 5 of those. 1, 2, 3, 4, 5. 4s, I had 8 of those. So here's 1, 2, 3, 4, 5, 6, 7, 8. Okay, the 5s, I had 6 of those. 1, 2, 3, 4, 5, 6. 6s, I had 5 of those. 7s, I had 3 of those. 3 8s, 2 9s, and a 10. Okay, so I've done this correctly. All right, so now I'm ready to go and calculate some stuff. So I'm going to go Stat, scroll over to Calculate. I want to calculate my one variable statistics, so press Enter. And your calculator is going to say, Mr. Manise, do you want to do it on list 1? Yes, I do. If I wanted to change this to list 2, I could go second. The lists are down here, L1, L2. I could change this to second L2 if I wanted to, but I don't want to do that. I wanted to do the calculations based on list 1. So go ahead and press Enter. Don't worry about frequency lists. Press Enter. Yes, I want you to calculate, and it's going to calculate a whole bunch of stuff. Okay. All right, so my first thing up here, this X bar, this is my mean. That's my average. Okay, so my average is 4.775. Let's just go ahead and round that to, actually, go this way. Okay, let's go ahead and round that to 4.78 is fine. All right, the median, where's the median? Okay, let me just go through these real quick. because I don't think I've done this on a previous video. Summation of x just means you add up all your raw data values. Summation of x squared means you take that value and you square it. We don't really use either of those two numbers. This SX means sample deviation, sample standard deviation. We don't want that. We want the entire standard deviation. So we don't use this SX either. What we want is this guy right here, sigma. Sigma x, that's my standard deviation. N is the number of data points that I have. And it's a good practice to count these and make sure that you indeed do have 40 points on your dot plot or wherever the data is located. Okay, there's my min, there's my Q1, there's my Q2 or median, there's my Q3, and there's my max. So your calculator does all these for you. My median is Q2 right there, 4.5. My IQR is Q3 minus Q1, represents the middle 50% of the data. That's just 6 minus 3, which is 3. You can see that. Okay, my range is just the max minus the min. Okay, so the range is 10 minus 1, which is 9. And the standard deviation is the sigma back up here. This guy right here, okay. 2.30, if we round that to 2 decimal places. Okay. All right, so there are our measures of spread. Tells me how the data is dispersed. Okay, so for 6 through 8, it says use a normal distribution and empirical rule, normal distribution curve and empirical rule, and approximate the following. So I've got my little cheat sheet over here. So here's our normal distribution curve. If our data is normally distributed, forming a normal bell curve, 68% of the data, or 34 and 34, 68% is right here in the middle, between one standard deviation below and above the mean. Okay, 95% of the data, if you recall, 95% of the data is within 2 standard deviations of the mean. Negative 2 standard deviations on the low side, 2 on the high side, and then finally we have the 99.7% number is within 3 standard deviations above and below the mean. Okay, so this first question is asking what percentage of the data is above the mean. Okay, above, below, really that means left and right. What percentage of the data is higher than the X bar? Okay, that's this part of the chart. Okay, this upper 50% is higher or greater than the mean. So that's just 50% of the data. That's easy. What percentage of the data is 1 standard deviation below the mean and 2 standard deviations above the mean? Okay, so we're sitting at 1 standard deviation below, so I'm sitting right here. Okay, I'm not going to circle back because I'm going to use this for a few more problems. I'm sitting right here at -1 standard deviation below and 2 standard deviations above. So I want, I'm not going to shade this, but if I would, I want all of this data between -1 standard deviation and 2 standard deviations. So all I have to do is add the 34 plus the 34 plus this 13.5%. Okay, and I would encourage you guys to memorize these numbers. You can figure it out mathematically like we did in class, but I would encourage you to memorize these. Okay, so I have the 68, the 2 34s, plus that little 13.5 piece, and that gives me 81.5. 81.5% of the data, a big bulk of the data is in this zone between -1 and 2. All right, what percentage of the data is within 2 standard deviations of the mean? So I'm -2 on the low side and I'm 2 on the high side. Well, that's just this guy right here. 95% of the data is within 2 standard deviations on either side of the mean, the average. So that is 95%. Okay. Find the Z-score, and you guys are going to have to memorize these formulas. Okay. The formula for Z-score is equal to the raw data. Okay, your X raw data value minus the mean divided by the standard deviation. Okay, so they're asking find the Z-score that corresponds to a raw score. Okay, there's my raw score. That is my X. Okay, and a mean, that's my mu or X bar, depending on how you look at it, with a standard deviation of 12. So there's my sigma. Okay, so all you can do, guys, is just plug and chug, plug it into the formula. Z-score is equal to X bar, that's going to be 25, minus the average, which is 35. Now my raw data is below the average, so I'm already anticipating that the Z-score is going to be negative because I'm to the left side. I'm somewhere over here to the left side of the average. Okay, divided by the standard deviation of 12. Okay, once again, show this one more time. I did this on the quiz review video, but in case you guys didn't watch that. When I do this, you cannot type in 25 minus 35 divided by 12. Or, oops, 25 divided by 25 minus 35 divided by 12. You can't do that, okay, because that's order of operations. Okay, if you're going to do this in one swoop, you've got to put that in parentheses up top. 25 minus 35, close the parentheses, divided by 12. Notice you get a totally different answer. It doesn't make sense to have a z-score of 22 anyway, okay, so use some common sense, all right? So we've got a z-score of negative, and I already anticipated that it was going to be negative. Negative 0.83. And remember, guys, we want to round our z-scores to 2 decimal places. 2 decimal, because on our table, our z-score table, we only have 2 decimal places. The left column is 1 decimal place to the tenths, and the row on top is your 2 decimal places, or to the hundreds. Okay. Z-score of negative 0.83. Number 10, a z-score of negative 0.5 was found, coming from a normal distribution with an average of 80. Okay, there's my mu. And a standard deviation, there's my sigma of 14. Now the z-score, now this time, normally we're trying to find the z-score. This time they give it to me. But I'm still going to use this formula, z equals the raw score minus the mean over the standard deviation. So let's plug in what we know. Now I know what the z-score is. It's negative 0.095. That's going to be equal to this raw value. It says find the raw value. That's what I'm trying to find, x, minus the average, which we said was 80. That's my mu, divided by the standard deviation, which was 14. Okay, how do I solve this? I'm going to multiply both sides by 14. Excuse me. 14s will cancel, so I'm going to have x minus 80 is equal to 14 times negative 0.95, negative 13.3, and I'm going to add 8 to both sides, and my raw data value is going to be equal to 66.7. Okay. And ask yourself if that makes sense. Okay. We're sitting at a z-score of negative 0.95. That's about negative 1. Okay. So we're sitting we're right here, very close to that. Okay. So if I'm right at negative 1 standard deviation, and the standard deviation is 14, doesn't that mean I'm about 14 below the average? 80 minus 14 would be 66, right? But I'm not quite there, so I should be somewhere close to 66, which I am. So use some common sense when you get your final answer. Okay, normal distribution with a mean. Okay, there's my mu of 7. Standard deviation of 2.3, that's my sigma. And what percentage of the data is between 6 and 10 minutes. Okay. All right. Now, if we're using a normal distribution curve and we've got these nice, pretty standard deviations up here, I'm one lower than the mean, I'm 2 standard deviations above the mean, then yes, guys, you can use this chart. But remember, I taught you guys day one, these values here are approximate values. Approximately, we would anticipate 68% of the data to be between negative 1 and 1 standard deviation. Okay, I would anticipate about 13.5% is between negative 1 and negative 2 standard deviations. The exact values, guys, are going to come from the z-scores and the z-score tables. Okay, and I can't use my normal curve here because if they're asking about 6 and the average is 7 with a standard deviation of 2.3, that's not going to be a nice pretty number. So that tells me, hey, I'm going to have to use z-scores here. So the first thing I need to do is when you see the word between, again, that should be a red flag too when you're using z-scores. Hey, I'm going to have to find 2 z-scores and 2 percentages. Okay, so I need to get the z-score for 6. Okay, so the z-score for a raw data value of 6 is going to be equal to that raw data value minus the average, which was 7. And then we're going to divide that by the standard deviation, which is 2.3. That comes out to be a z-score of negative 0.43. Okay, let's go find the z. I'm going to give myself a little space here. Let's go find the z-score for the 10. Okay, z-score 10 is going to be the raw data of 10 minus the average of 7 divided by the standard deviation of 2.3. Plug that in your calculator, that comes out to be 1.3. Now, one of the mistakes I noticed on the quiz, guys, was some students were actually subtracting the z-scores. Okay, we're not going to be subtracting z-scores. We want to find the difference between the percentages. So once I find this z-score, I've got to go to my table and find what percentage that corresponds to. Okay, so let's go to, now I'm on the negatives. Remember, there's a positive and negative on the z-scores tables. I'm in the negatives, so I'm going to go to negative 0.43. Okay, there's negative 0.4. And then I got to go up here to 0.03. This is my tens place. These are my hundreds place. So I simply find where the 0.3 number matches the 0.4 number, and that's going to be this guy right here, 0.3336. Okay, so a z-score negative 0.43 corresponds to a percentage of 33.36%. Okay, so that's going to correspond, I'm just going to draw like a little arrow right here, and that's going to correspond to 0.3336. Okay, now I got to do the same thing for the positive 1.3. You got to turn your table over, go to positive 1.3, and it's just 1.30. Okay, so I don't need to go across the top. I'm just sitting right there, 0.9032. 9032. And now I'm ready to subtract that percentage from that percentage. And you can subtract the decimals and then convert it to a percentage, or you can go ahead and convert these percentages and then subtract the percentage. It doesn't matter, you get the same answer. So now I'm simply going to do the 0.9032 minus the 0.3336, and that comes out to be 0.5696. Sorry, I can't see that. I'm just going to go ahead and move the decimal place 2 spots. That's going to be 56.96%. Okay, so 56.96% is between of the data is between these two values. Okay, number 12. What percentage of seniors scored between 350 and 360? This is literally what we just did. Same as that problem. It's just a different scenario. So we've got some seniors taking a section of the SAT, and we had an average of 500. That's our mu, standard deviation, that's our sigma of 90. And it's telling us that it's bell-shaped, so we can use the empirical rule. And so there's that word between, so that's telling me, hey, I'm probably going to have to find 2 z-scores and 2 percentages. So let's find the z-score for 350. That's going to be the raw data minus the average, which was 500. I'm less than the average, so my z-score is going to be negative, divided by the standard deviation of 90. That comes out to be negative 1.67, which I buy that. Sounds right to me. The z-score of 600, this guy, that's going to be positive because I'm above the mean. 600 minus the average of 500 divided by the standard deviation of 90. That comes out to be 1.11, as you might expect. Standard deviation is 90. We're 100 above the mean. So shouldn't our standard deviation, or z-score, which is the standard deviation, shouldn't that be somewhere around 1? Well, yes, it should, Mr. Medice. It should. All right, so let's go to the table. I'm going to use the table. Let's go find those percentages. All right, I'll start. Let's go with the negative 1.67. Here's negative 1.6, and then I got to go across to the 7s. So just use your fingers and track that down. That is going to come out to this guy right here, 0.0475. Okay. 0.0475, and let's go to the positives. Let's go to 1.1. That's this guy right here, and it's 1.11. So there's 1.1. Here's the 0.01. So that corresponds to that percentage, 0.8665. Okay, and now I'm ready to subtract the 2 decimals, or the 2 percentages. 0.8665 minus 0.0475, move the decimal place 2 spots, and that comes out to be 81.9%. And again, that makes sense. I'm almost at -2 standard deviations on the low side. Okay, so I'm here somewhere, like negative 1.67, and I'm a little bit above 1 on my curve. I'm sitting here at about a 1.11, okay? So it's not quite 95%, right? Because 95% would be within 2 standard deviations. Well, I'm 2 on the low side, but I'm only 1, a little bit above 1 on the high side. So I would anticipate something less than 95%, but somewhere in the ballpark. So yeah, 81.9, 82%, yeah, I buy that. Sounds reasonable to me. All right, let's flip on over. Okay, letter B. One student scored a 790 on the test. How did this student compare to the rest of the class? Okay, well, we're still using all these same values here. Okay, so when it says how did the student compare, you could say, you could use a percentile, or you could just say the student did better than such and such percentage. So in either case, I'm going to have to get a percentage from the table, which means I need to do what first? I need to find my z-score before I go to the table. So that's going to be my raw data, 790, minus the average, which was 500, over the standard deviation, which was 90. Okay, and then that is going to give me a standard deviation of 3.22. Wow, 3.22. Holy cow. 3.22. I'm way out here. 3.22. So that's going to be very, very close to 100%, right? Because 99.7% of the data is within 3 standard deviations. If I'm a little bit outside of that, I'm an extreme outlier, okay? So let's take this z-score. Let's go to our table and find 3.22? 3.2 way down there, and then 0.2 up here. So if you follow that with your fingers, that gives me this guy right here. And as we can see, all these guys down here, once you get up above 3 standard deviations, man, you are really, really close to 100%. There's not a whole lot of difference in these numbers, okay? So that's 0.9994. Move the decimal place 2 spots, and that's going to be 99.94%. Okay, so there is your valedictorian or salutatorian, right, at the top of the class. Okay, so how I actually answer this question, how did the student do? You could say one of a couple things. I could say they did better than 99.94%. Okay, or you could say they're in the 99.94th percentile. Okay, either of those answers would be acceptable. Okay, part C. A rather exclusive university only admits students who were among the highest 10%. Okay, so this is just like the problem on the quiz. If I'm in the top 10%, what percentile am I in? I am in the 90th percentile, right? I have done better than 90% of the people if I'm in the top 10%. Okay, what score would a student need to make on this test to qualify to get into the university? Okay, so most of the time we have the z-score and we're going to go to the percentage. Okay, I have the z-score, I go get the percentage. But now we're going to actually work backwards. Now I have the percentage and I need to go backwards to find the z-score. Okay, once I have the z-score, then I can plug it into my z-score formula. Z equals x minus the mean over standard deviation, and I can figure out, back calculate what that raw data value is. Okay. All right. So how do I get the percentage? Come on, camera. Sometimes it loses focus. There we go. All right. So I need to go to my table and figure out where is 0.9. What is the percentage that is the closest to 0.9 or the 90th percentile? Okay. Obviously that's going to be in the positives because I'm to the right of the mean. Okay. So I'm looking for 0.9 somewhere. 0.9. Okay, there's 0.9. That's 0.9015. This is 0.8997. So this is only 3 away. This guy is 15 away. So this guy right here is actually the closest decimal, the closest percentage to 0.9. So then I got to go work backwards and follow, use your fingers there to go backwards. Say, okay, I'm at 1.28. Okay. 0.89997 or 0.9 corresponds to a z-score of about 1.28. Okay, so I'm going to say Z is approximately 1.28. Okay, now I'll plug this guy into my Z-score formula and figure out what the raw data is. 1.28 is equal to the raw score, which I'm trying to find, minus the mean, which was, that was 500, right? Divided by the standard deviation, which is 90. Multiply both sides by 90. Let's cancel. Oh, I didn't mean to cancel that. Multiply both sides by 90. So I get 1.28 times 90. So I get 115.2. I get 115.2 equals x minus 500. Add 500 to both sides. And you get x is equal to 615.2. Okay, but we're talking about a test score here, right? So if you wanted to round that to 615, okay, of course that would be fine as well. Okay, number 13. This is a good real world problem, talking about money and rent and house payments and apartments. So we have the average cost of a one-bedroom apartment in Tennessee is $1,100 per month with a standard deviation of $180. So assume that the data is normally distributed. What percentage is between? Okay, so I'm already thinking, okay, I got to get two different z-scores here. So the z-score for 1100, and guys, for sake of time in the video, I've already done enough of these. Y'all can do this. Plug in the numbers. 1100, your data value 1100 minus the well, actually, I'll just work this one out because this one's a little bit different. So here's our normal raw score, 1100 minus the average, which is 1100, divided by the standard deviation, which is 180. Well, what's 1100 minus 1100? Oops, 1100 minus 11, that's just 0. 0 divided by 180, guess what? That's 0. Okay, so if I got a z-score of 0, okay, well, you should be able to figure this out. Think about it. Z-score just means standard deviation. So if I'm sitting at a standard deviation of 0, then my percentage is 50%, right? Because I'm literally sitting right in the middle. Okay, 50% right in the middle. Okay. All right, so I've got a z-score of 0. That corresponds to a percentage of 0.5. Okay, the z-score for the other guy, for the 1500, again, I'm just going to kind of skip that, let y'all type that in your calculator. You should have gotten a z-score of 2.22. There's 2.22. So follow that, track that down. That comes out to be 0.9868. Okay, 0.9868. And now I'm going to simply subtract 0.9868 minus the 50%, and that comes out to be 48.68%. Okay. Caitlin's father says he's only willing to spend $1,200. That's real world, or less on an apartment. You know, my wife and I are thinking about buying a new house, and we're looking at our budget and figuring out, how much do we want to spend? We don't want to spend more than $1,300 a month on a house payment. Okay. What percentage of apartments does this include? Okay, maybe this is not the city for him. If it doesn't work out, if you don't want to spend more than $1,200, don't go to California. It's not happening. Okay, out in California, a $100,000 house in California is about the same thing as a $400,000 house here in Evans, Georgia. All right. So, what percentage does this include? Okay, so I've got to find the z-score. Okay, the z-score of 1200. Again, I'm not going to plug that in. That comes out to be 0.56. Okay, let's go to the table. 0.56. That gives me this guy right here, 0.7123. By the way, guys, always write a leading 0 in front of your decimal. Don't do this. Don't be one of those students who does this. Okay? it's just too easy for you to make a little, like, there's a little mark on my paper. Is that a decimal or not? You know, it's just hard to tell. So I'm a bit advocate of always putting that leading zero. That way there's no mistaking what's going on here. Okay, so that gives me a z-score of 0.7123, and so that's my percentage. That includes 71.23%. Okay, so that's a pretty good chunk of the city. So if you're only willing to spend $1,200, that's about 70% of the houses. That's still a good wide range. What if we were to lower this and say I'm only willing to spend $700? Well, if we calculated that, that would probably come down to, like, I don't know, 10%, 15%. Okay, maybe that's not the city for you. You don't have very many options. What percentage of apartments cost more than $900? Okay, so there's that trigger word more. Okay, so let's go get our z-score. Z-score for $900. Again, you just do 900 minus the average divided by the standard deviation. That comes out to be negative 1.11. Okay, so let's go to our negatives on the table. There's negative 1.1. Here's the 0.1, so track this down. That's going to give me this guy right here, 0.1335. So 0.1335, that's about 13%. Okay, but now it says more. Okay, so on the curve, I'll grab my curve again. I'm sitting here at a z-score of negative 1.1. Okay, so I'm sitting, oops, sorry, I can't see that. I'm sitting about right there. I want more than. I want all of this data to the right. Okay, when you're looking to the right, guys, when you're looking at data to the right side of the chart, you've got to subtract that from 1. Okay, normally we say, okay, I'm sitting here at a standard deviation of 2.4 or whatever. I did better than how many people? In that case, I'm looking at all the data to the left. I want all this stuff. Okay, so when it says less than or below, whatever percentage you get, that's the number. When it says more than, you're looking at data to the right. So I've got to take this number and subtract it from 1. So 1 minus 0.1335, move the decimal place 2 spots. That gives me 86.65%. Now let's think about it. Some of you guys will get these confused. When do I subtract from 1 and when do I not? If you can't remember and you get that confused, if you didn't do this, guys, you would say that the answer is 13%. Now think about that. The average is $1,100 a month with a standard deviation of 180, and you're saying that only 13% of the city is over $900? That can't be right, okay? So I'm already thinking, okay, this, if it's over $900, that's pretty cheap. That ought to be a big bulk of the houses. Again, use common sense. Ask your answer. Ask yourself, does my answer make sense? Don't ask your answer anything, it's not going to respond. Okay, so what percentage of apartments cost between? There's that word between again. All right, so we've got to get 2 z-scores. So let's go get a z for 950. Okay, plug and chug. That comes out to be negative 0.83. And the z for the 1300, plug and chug, that comes out to be 1.11. So by now, hopefully you guys are getting good at this. If you haven't already, haven't mastered it yet. Okay, so I'm going to the negatives. I want negative 0.83. Okay, there's negative 0.8. And then I've got to match that with 3. So come down here. That's going to match up with that guy right there, 0.2033. 0.2033, it's about 20%. And then the z-score for the 1.11, I think we already did this, didn't we? Yeah, that's this guy right here. We already did that, 0.8665. 0.8665, okay? And I'm going to subtract those because it says between. So 0.8665 minus 0.2033. Move the decimal place 2 spots, and that comes out to be 66.32%. Okay, I buy that. Between $1,300 and $950, I buy that. 2/3 of the data is between those $2 amounts. If this data represents a sample of 18 apartments, use a confidence level of 95% to find the margin of error, guys. So with the margin of error and confidence interval, confidence levels, there are only 2 things you're going to do. You're either going to find the margin of error, That's the first thing, find the margin of error. And then they're going to ask you for a confidence interval, and you're going to take that margin of error and you're going to add it and subtract it from the average to get your interval. I want to say my data is between this point and this point. Remember, I'm trying to find the unknown population mean. I don't know what it is, but I'm going to use a confidence level to say I'm 95% confident that the actual true average based on my little sample is somewhere between him and him. Okay, a confidence interval. All right. So the first thing I got to do is calculate the margin of error. You guys are going to have to memorize this formula. Margin of error, ME, is equal to your critical value, that's that Z-star value, which I will give you, I'll have that on the board for your test, times the standard deviation divided by the square root of the number of samples. Okay, this is talking about a 95% confidence level. All right, so the Z-star for a 95% confidence level, that was your 1.96 number. Okay, 99 was 2.58. 90% was 1.64, but you don't have to memorize those. And now it's just plug and chug, guys. I'm just going to stick in a 1.96 here. So 1.96 times my standard deviation, which was, what's our standard deviation? Times 180. Okay, divided by the square root of the number of samples. Okay, how many are we talking about? We're talking about 18 apartments, so it's the square root of 18. All right, type all that in your calculator. 1.96 times 180 divided by the square root of 18, and there is my margin of error. Okay, 83.16. Margin of error equals 83.16. What are we talking about here? I would prefer to see the plus or minus, okay? If you don't write plus or minus, I'm not going to take off, but this insinuates that we're 83 above and we're 83 below. What are we talking about? We're talking about money. So the margin of error is $83 above the mean, $83 below the mean. Okay, so in the next one in F, they're going to say, okay, get your margin of error and then add and subtract it from the mean to get a confidence interval. Okay, write a confidence interval. Now this time we're using a confidence level of 99%. Okay, so the Z-star for the 99%, that was our 2.58 number. Okay. All right, so we gotta get margin of error. That's gonna be equal to that 2.58 critical value times the standard deviation, which is 180, divided by the square root of our 18. We still got 18 apartments that we're looking at. Okay, so plug that in, and that comes out to be plus or minus $109.46. Okay, 109.46. Now we've got to create a confidence interval. Okay, so for the interval, I've got to take that number. All you do, guys, is you add it to the mean and you subtract it from the mean. Okay, so I'm going to do 1100, our average, plus 109.46. And I'm going to do 1100, our average, minus the 109.46. That's going to give me two different numbers. That is going to give me a 1209.46 on the high side, and on the low side, that's going to give me 990. Is it 990 even? 1100 minus 109.46. Technically it's 990.54. Okay, so my unknown population mean, which is the whole purpose of doing all that, is going to be bigger than the low number, the 990. Now we're talking about prices on a house, guys. Okay, so you know I'm probably just going to round that to $991, and on the low side I'll just say it's going to be less than $1,209. Okay, we're talking about money. So there's my confidence interval. So what we're saying here is I'm saying that I'm 99% confident that the actual true average of all these apartments in whatever city we're talking about is going to be somewhere between $991 bucks and $1,209. Okay, that's our confidence interval. Okay, so if you're not sure about that, pause the video, rewind it. YouTube is an amazing thing. Okay, rewind, go back and listen to it again. All right. Number 14, you're going to have to do this on the test. You got to figure out whether or not there's an outlier. Okay, I'm going to give you some data, and you got to do the 1.5 IQR rule. Okay, so IQR times 1.5. So we got to go back to what we did at the beginning. Let's type this data into our calculator. So let's go stat, press the stat button. Let's edit our list. Now you could do this in L2 if you wanted to. I'm just going to go up here and clear it. Clear, enter. I'm going to make a new list. 26, 30, 17, 28, 35, 31. Go back, guys. Go back and check. Make sure you didn't miss a number. 26, 30, 17, 28, 35, 31. Good to go. Okay. Press the stat button. Stat. Now I want to calculate. Scroll over. Press the little scroll button. Scroll over to calc. Press enter. Ask your webcam to refocus. Your webcam obliges. Yes, I want to do the calcs, the one of our stat calcs on list 1. So press enter, enter, yes, yes, and it calculates our stuff. Okay, so now I need the IQR. Okay, that's Q3 minus Q1. Okay, so in this case, my Q3 is 31, my Q3 is 31, Q1 is 26. So my IQR is 31 minus 26, which is 5. I'm going to take this value, the IQR, times 1.5. 5 times 1.5 is 7.5. Okay, so now I'm going to take this number and I'm going to add it to the Q3 and I'm going to subtract it from the Q1, and that is what will give me my bounds, my upper bound and my lower bound, to say whether or not a number is either higher or lower than that to determine whether or not it's an outlier. My Q3 was 31 and my Q1 was 26. Okay, so I'm going to add 7.5 to the Q3. That gives me 38.5. I'm going to subtract the 7.5. I'm going to subtract the 1.5 IQR from 26. Okay, that's going to give me 18.5, and there are my bounds. If I have any number higher than 38.5 or less than 18.5, then I can say it's an outlier. Do we have any of those? Yes, I do. I have one that's barely an outlier. 17 is less than 18.5, so therefore 17 is an outlier. Okay, so we've answered that question. Yes. How do I know? 1.5 IQR rule. When to use the mean versus the median? Okay, this is easy. You're going to use the median when there is an outlier or outliers. Okay, you can use them if there are no outliers. Just use average. Use the mean. That's fine. All right, home stretch here. The last 4 on the sample stuff. Simple random. It says give me an example. Simple or random. Of course, answers vary. Mr. Manise's iPad. This is what I do with you guys. I assign you a number. I let my iPad randomly call on a number. That way it's perfectly fair for everybody. Systematic means every 10th one, or you got a car part assembly line in a manufacturing plant. We're going to pull every 100th part that comes off the line every time. Okay, and we're going to inspect that car part. Or we could say I'm going to pull every 5th student who walks in the door. Walking through the door. Okay, those two are easy. These are the two that students get confused. What's the difference between stratified and cluster? I explained this on the quiz review video, but I'll explain it again. So, yes, I'll do this piece of paper. Okay, stratified is you got a group. You're going to divide that group into groups based on some specific characteristic. Divide them into sports, divide them into musical instruments, divide it into what kind of food you like. And then from each of these groups, I'm only going to poll just a few. Maybe I'm only going to poll 3 from each group. I'm going to randomly ask 3 people. Okay, that is stratified. Think about layers. Okay, stratified clouds, layered clouds. Okay, that's stratified. Cluster means, for the most part, I already have my pre-existing groups. Okay, I already have my sports, I already have my musical instruments, and I'm going to poll, say if there are 10 people in this group, I'm going to poll all 10 people. If there are 15 people on the tennis team, I'm going to ask all 15 people on the team. Okay, so we got 40 guys on the football team. We're going to poll all 40 guys. Okay, polling everybody in the cluster. So that's the main difference. So stratified, I'm going to say, oh, actually, you know what? Okay, I'll write it out. Separate students into groups based on whether or not they like college football. Do you think Mr. Manise likes college football? I'm going to separate him into groups based on who likes college football and who doesn't. And then ask 3 of those people. I'm going to ask 3 of those people. Do you like Clemson? Do you like Georgia? Okay. Cluster means I'm going to do the whole thing. So an example of this would be I'm going to ask all juniors. I'm going to ask all seniors which college they plan on attending. Okay, the cluster groups are already formed. We already have juniors and seniors, and then I'm going to ask every single one in that group. That is your cluster. Cluster is everybody. Stratified is just a few. Okay, so there you go, boys and girls. Hope you guys enjoyed this video. Hope you learned something or figured out any misunderstandings that you may have had. I wish you guys the best of luck on your test, and we will see you on the next video.